Hey, what's up, guys? Welcome back. In this video, we're gonna learn or see how to define the domain and range of the cosine function, right? We're having two functions here. They are both cosine. One, the first one, f of x, with a cosine of x, and g of x with two cosine of x. The only difference here is that one have an amplitude of 1 and the other one an amplitude of 2. We're gonna see that when drawing out the curve. First of all, First of all, we will draw the two functions and then interpret their domain and range, right? Just like we did in a previous video with the sine function, we will need to, to make a table of values of the function cosine, having x here and its image cosine of x. So try to find the different values of that function on a xy coordinate. Okay, when we have in here, we will start here at 0. This is the point 0 here, right here, right? We start here and go along the curve that way, anti-clockwise. Okay, and come back here. So we've made a 2 pi, circle. And if you take the opposite direction anti-clockwise, of course, you'll be making a minus 2 pi circle. And anytime you stop, like here, you're having a pi over 2, or you're going onto there completely. This is 180 degrees, but since we're taking the radians, it is pi, which is equal to 180 degrees, of course. And you go in the opposite direction, you'll be having here minus pi. So we will start with our first value 0. We were looking for the cosine of 0. When we stand in here, okay, we'll be reading the value of x. I mean, remember I told you in the previous video that all the cosine values are read on this line here on the x axis. So this coordinate here, 1 and 0, has has an x value 1 and a y value 0. When we were doing the sine, we were more focused on the y value. Now we are looking for the x value. And when you stand here, of course, the cosine of 0 is 1, right? We're having 1. Now, when you move along the circle and stop at pi over 2, you're having the value of x is 0, okay? So we write here the cosine of pi over 2 will be equal to 0, right? And we'll continue moving and stop at pi, and the cosine will be minus 1. So we have here pi and the cosine is minus 1. Then we continue at minus pi over 2. And remember, minus pi over 2 could also be written like 3 pi over 2. Okay? And 3 pi over 2, when we stop here, the value is 0. Remember, we're taking the x value. Okay, so 3 pi over 2, and the value is 0. Its cosine is 0. And when we take now, we move back to the starting point at 2 pi, the cosine would also be 1. That's what we did when we were starting. So we're going to take here 2 pi, and its cosine is 0. 1, pardon. Not that 0 before. It's 1. Okay, so we have our table of values. Now we can draw this first function before going to the second one. All right, well, we need 0 here. This is 0. We say that, first of all, I need to locate the value on a xy coordinate, on an x coordinate. We're having the first one, it's 0 over here. This is 0 right here, and its cosine is 1. So it is at 0 and 1. That might be somewhere here. First of all, I need having pi over 2. Let me put pi over 2 like right here. And I'm having pi right there. And this is a different color. It is a different color. I'm putting pi here. And going to 3 pi over 2. 3 pi over 2 is a yellow color that I put it here. 3 pi over 2. Then I go back to pi 2 pi of course, and 2 pi will be right here. All right, we can even extend our table values here. If you want to have the value of minus pi over 2, I mean this way. I'm having here minus pi over 2 and minus pi over 2 we stand here. Okay, we're looking for the x value will be 0, and of course minus pi will be equal to -1. All right, okay, we have all our values. So now we can just just draw out the function. um the we're having here, just put this value right here, minus pi over 2, and then minus pi. And of course we are in a unit circle, so it means that our circle is not more than 1 and -1, -1 and 1. Okay, and as we're gonna have a an amplitude of function a little bit bigger, so we can even put 2 here, because we're going to have an amplitude a little bit bigger here, and put -2 right here. Okay, now we can draw our function. We say that when x has the value, when x has the value 0, its cosine or its image is 1. It is this point here, it is 1 right there. So I'm going to put green dot there. And when x has the value pi over 2, its cosine is 0. Pi over 2 is 0 right here. Okay. And when x has the value pi, its cosine is -1. Somewhere here. Right. And when pi 3, when x has the value 3 pi over 2, we are having 0. We're going back on the x-axis. So we value 0 here, and therefore going 1 again with 2 pi right there. Okay, doing the same thing this side here. Minus pi over 2 is 0. It is right here, the x-axis, and minus pi is -1 right down here. All right, so now we just need to connect the dots to have our function. Okay, so I'm gonna start right here. We said this is here -1. Okay, minus pi, so the function will be doing something like this here. There, here, and also there. All right, so I can just connect them by doing stuff like this, going through 3 pi. Okay, got it here. Then going down here over 2 pi. All right, and here over -2 pi. Okay, and continue somewhere there over 3 pi and something. So I can just do it like this. All right, and this one will be going down, touching. Um, we're gonna be here 2 pi, 2 pi, that'll be 5 over 2, I think. So something. Okay, but this is how our function look like, right? This is the cosine of the function. We have it. Now we need to find the domain of this function, right? Um, but before doing that, we can even draw out this g function. And as you can see, I told you before, this function has an amplitude, and its amplitude is this, distance right here, which is 1. It's not there really on it, right here. This is its amplitude, and it is the same thing here, here again, and there. It's going to continue to be the same every time we move along the unit circle. So the amplitude here is 1. Okay, we can just write an A there to mark it as an amplitude. So this is what we got here. The amplitude here of this function is 1. Put it a different color. And that's what that's what makes a difference between this function and that other one. So now we're not having only the amplitude 1 but 2. It means that the function will be describing the same curve but twice. I mean, like a little bit higher until here. So what we can do is we just put in a dot here, put in a dot there, because going here across this one here, and put in a dot here, there, and on the top here on 2, for example. Just to have the amplitude 2. That's what we're trying to do. Got it here, got it here, got it right here, and right there. All right. So we need I mean, just like we did before, just to connect the dot, of course. Okay, and right here. I mean, just try. It's not really my thing, but I'm trying to do my best. Okay, the function will be dropping down here to pi over 2, connect to this point here, and then here dropping down to 3 pi over 2 and connect to this one here, and also going down here to minus 2 pi and connect to this one here and continue over there. All right, that's exactly what our second function looks like, something like this. Okay, so that's our second function. It's not really good here. Maybe change a little bit here. This side here is not really what I want to have. Okay, let's just have it like that. Okay. All right. This actually how our function looks like. Okay. We got a cosine. We got a 2 cosine. This is the function g. Let me just put g here, and with 2 cosine. And this 2 actually means that we're having an amplitude of the function equals to twice to 2. I mean twice the amplitude of the first function. So this is here a1 for this amplitude, and a2 will be the amplitude of the other function. So we can describe it just from here to there. With a grid line right there. And that's the amplitude of the second function. It is the same thing here, right? And it's the same thing here. I should have done it, the side, not to cover the other one. But all right, then you understand what I mean with that. And the amplitude here is until. So that's the amplitude of the second function. We will call it a2. It is here the amplitude a2. And the first one was the red one. It was the amplitude 1. All right, and this is we got here. The amplitude 1 is this one here, and the amplitude A2 is this amplitude here, 2. Okay, this is our function. This is how we can draw our function. Now we will answer to the question that we had at the beginning of this exercise. We need to find the domain and range of the cosine function. This is what we're going to do now. So actually, the domain of this function, if you just take a great look, you see that the domain of this function, like we said, the domain is all about the x value. Okay, all the values that are on x-axis. So what is it? If you just take a look here, you see that we're going from minus infinity to 0 right here to plus infinity. So the domain of this function is taking all the value of the real numbers. So that would be all real numbers. And real numbers are written R. Okay, you can also put in the interval saying that it is minus infinity until plus infinity, and it's open. Sorry, it needs to be open because we don't know really what infinity is, what value infinity is taking at that moment. So it is open here. The bracket, square bracket, is open right here. All right, and that was the first question. The second question now, and of course this is for the f, this is for the, let me just put it again. I just do that a different because both functions have the same, you know, domain. So I'm going to do it like this, saying that for the f function, let me put df. Okay, the domain is R, and this is what we say here, minus infinity until plus infinity. And for the orange function g, the domain also, sorry, I mean dg here, the domain is also minus infinity until plus infinity, because it's describing exactly the same thing, but a little bit, you know, with a higher amplitude in the same direction, covering x from minus infinity until plus infinity. Now, what about the range? The range, let's say, just put it again. The range is about all the value that are all the x, the y values, of course, right? So we will say for df, its range, or I put it rf for range. The range of f will be equal to, so you can see f is describing, you know, kind of a curve, you know, going from -1 to 1 and so on. All right, and it is in this, you know, in these limits here from -1 to 1. Oh, I forgot to put -1 here to 1. This is where our function f is defined on the x, on the y value. So its range actually would be from -1, -1 included, of course, and 1 also included. And what about the range of g? Its range is also described in this, you know, in the y-axis, but it's having one, you know, 1 digit or 1 unit more than the f function. So we will say that you can see we're taking from it, that's what we call the amplitude. That's what we're making a difference. So it was 1 here, so we're having 2 now. So it's describing from here, from 0, 1, and 2, and doing the same thing, 1 and 2. So from -2 to 2, and this is here the range of that function. Oh, okay. I put an additional minus here. It's not. This is 1. Okay. All right. So that's how you can define, you know, whenever you have an additional amplitude on your function. So you can just, you know, just like considering that your function is having the same, I mean, the amplitude of the beginning plus odd times other unit on it. So it's giving us like a two amplitude here, where we have one for the f function. And this is how we can, define our domain and range of the cosine function. Thank you for watching again, guys. Until next time, bye bye.